Going live, going live, going live. All right. Welcome back, everybody. Good afternoon. Hope you're all doing well. So let's go ahead and jump in today. Today we are going to cover how to actually take our trained model pickle file that we created in the last session and actually use it as part of an API. And so we'll talk a little bit more about that in a bit. So just to let you know, I do have a hard stop today at about 5:45. My daughters are in a music lesson right now, and so when they're done, they're going to come home for dinner, and so I need to make that dinner for them when it's all done. Okay, so so recapping where we left off last time. So we had already done our feature engineering a couple sessions ago. We did our model training, and then I'm going to show you one more thing about the model training that we didn't get to that is going to be really quick, and then we're going to actually jump into creating our fast API itself. Okay, so let me go ahead and share my screen here. Okay, nice wallpaper. Okay, so this is where we left off. We just saved this simple pickle file, and then we showed how we got some metrics off of the train version once we reloaded it back up. So the one thing that we didn't do, and I actually went ahead and wrote all the code for this anyway, so if you want to get this code, you can go to my GitHub. So that's github.com/dkhundley, and then it will be as part of this, oh gosh, where is it at? The Titanic SageMaker BYOC. So if you go in the notebooks here, predictive modeling, you can see that I have made the same updates. Okay, so back to our file here. So what we did here, and the reason this is fine, what we did here, but I want to take it a step further. So, because what this is doing is it is serializing basically the coefficients of the mathematical algorithm that are running behind the scene just to do transformation, or I guess inference on clean data. But let's say you wanted to basically pass in raw data. So if you remember back when we downloaded the data set originally from Kaggle, we had all this data that, some of it wasn't relevant, some of it needed engineered in a specific way. So let's say you had a model API, and we'll talk about APIs again in a minute, where you pass in just raw data and you want to get the inference back out. Well, this by itself isn't going to cut it, because this pickle file that we have here is just for the inference transformation on top of already clean data. So if you want to do a full pipeline, what you're going to need to do, so let's just come back. Oh, this is the wrong notebook. So let me go back into the feature engineering notebook. So you might remember with the feature engineering notebook, let me go down to like the embarked column here. So with the embarked column, we created this thing called a one-hot encoding object. So let's say you wanted, the reason, if you recall, that we used this special object is whenever you pass in inferences on data and you want to consistently transform them, one-hot encoder here kind of saves this idea of knowing like how to transform things. And again, same with the simple imputer here with the age, imputing that median. If you wanted to consistently transform things every single time, then what I didn't share last time is you can actually export all of these objects as their own pickle files, and you could load them back up just like we did with our trained random forest classifier model, and to generate inferences. So you could actually save every single one of these little guys as its own pickle file. And that's totally fine and acceptable. And there are use cases of why you might want to do that. Let's say if you have a different process that is just doing the feature cleansing, then maybe you just want to have, or the feature engineering, then maybe you just want to have those pickle files do that over there and then have a separate process do the model transformation. But let's say you wanted to do it all in one and you didn't want to have to coordinate all these different pickle files. You might be wondering, is there a way to package everything as just one nice, clean pickle file? And the answer is yes, there is. So this is what I want to cover. I already did all of the coding just to save time, but we'll talk through conceptually. So here I'm just loading back in the original raw data to show we are using the raw data. So the only thing I did here was I separated our X from our Y, so the Y being the survive column and the X being everything else, and then doing the train test split on these. So the first thing that we need to do before we can actually bundle all these together is take our feature transformation logic and create what we call Python functions out of it. So if you're not familiar with what a function is, it is basically this idea that you put your inputs in and it does some fancy transformation, whatever it is, maybe not even that fancy, maybe some sort of transformation, and then you get something back. So in the case of this create age bins, function here, it is taking in a data frame df, and then we are doing all the feature engineering in order to return out the H dummies. And same thing here with this other create embark columns. And so the logic within inside of these functions here should look very familiar because it is the exact same thing from our feature engineering notebook. I just took the code that we copied out from some of the cells. I did change the name from like X to like a more generic DF here, and you don't have to name things like this is just the way I named it. DF is often the shortened version for data frame, like a pandas data frame. And so I got our three functions here that are doing our feature engineering. So for our respective features, so this is doing it for the age, this one's doing it for the embarked, and then as you recall, so this last one here isn't even using like a special pickle file, but it was easier to bundle it all together as one thing. Okay, so we with our functions in hand, we can go ahead and create what is called a column transformer, which is going to do all of our feature transformation. So this is the cell that runs all that. This what is known as cell 29 here, even though that'll change. That this is just the cell where which things are run. But anyway, it looks messy, but it's actually pretty simple to understand what you're doing. So like what this is doing is, so this is a scikit-learn column transformer, and then you hand it all your transformations that you want to do appropriately. So so you can see that here are three different engineering. So for each phase, there are three steps of each of these transformers. There's just the name that you want to call it. So this can be whatever you want to call it. Just to keep things simple, I called it the name of the feature with engineering. So age engineering, sex, gender engineering, embarked engineering. And then the second function, or the second parameter in here is what we call the column transformer. And so, or I'm sorry, not column transformer, the function transformer. So this is taking those functions that we had created from above and basically are using it as part of this pipeline. And then the third parameter of each of these transformers is the column in which we want to enact the transformation on. So we obviously are taking so this is our age engineering transformation. We want to use the create age bins function on specifically the age column. And again, so let's just cover this again with the next one. With our sex engineering function, we are passing in the create gender columns function and doing that transformation on the sex column. Same with embarked thing. And then in order, and then so the last two things here. So you'll recall from our raw data set that we dropped a couple columns that were irrelevant, that we deemed to be irrelevant. So here we are saying these are the columns to drop, and we want to drop these, and these are the ones that we want to drop. And then for everything else, and this is important to remember, that we didn't touch, so like the fare column, fare, F-A-R-E, like the dollar amount cost, we didn't touch that one at all. We want to make sure that everything else is set as pass-through. And the reason this is important to set is because if you don't set this, then it will only or only generate outputs for things that you explicitly define, and everything else just gets dropped completely. So like the fare column would get dropped if we did not include the remainder. So I know this looks messy, but it's actually pretty simple in concept. And then similarly for actually creating the inference pipeline, so we created our data preprocessor up here. We are taking the scikit-learn pipeline object, and we are creating two different steps here. So again, pretty simple. So this is just the name of the step. So our first step, so the name of our first step here is feature engineering, and we're taking from data preprocessor. And so, and then, setting it as our first step here. And then the second step is obviously going to be actually training against our reinforced classifier object using the same hyperparameters that we used with our hyperparameter tuning job. And then to actually train the pipeline is very similar to how we did the training of the model itself. It's just you take this pipeline object, which is we called RFC pipeline, fitting the training data to it, and then we can basically use it as if it is its own model. So you could see here that I used the RFC pipeline to predict with the validation data set, and then I got our metrics and everything, and it is working. And just like we saved out our simple model, we were able to save this also as its own pickle file. We call this RFC pipeline. And this is different from the other one. I actually kept the other one as RFC model. So there's RFC model.pkl and RFC pipeline.pkl, so you can see that Let me go in here. So within the models directory, you got two different flavors. And so that covers that. Again, there are use cases of where you would want to use that or where you wouldn't want to use that. I know we covered that concept really, really quickly, but that's because I want to get more into what the stream is entitled. It's talking about the actual creation of the API. So this is much more my forte. So like, as I mentioned before, I am a machine learning engineer. That title is differently defined from company to company, at least within my company. That means, or the company that I work for, that means that I partner with our data scientists where they are the ones creating the model. So that's what we did here, doing the feature engineering and then the actual predictive modeling in here. And then once they get it to this point where it is trained and like serialized as a pickle file, or maybe not even a pickle file, but serialized as something, we as machine learning engineers take it and then package it in such a way that it can be used by whatever other enterprise system. And so this is where this is much more my forte of the role. And this is also the point when we step out of Jupyter Notebooks, because Jupyter Notebooks are great for discovery and great for training, and well, actually, they're not great for training. Well, you can do training, but you shouldn't, and I can explain that another time. But anyway, so they're great for discovery, great for visualizations, great for explaining things with like these markdown things. But as far as actually deploying out, you don't want to use a Jupyter Notebook. And instead, we are actually going to write Python files using a text or a code editor that isn't within the Jupyter Notebook. So actually, from here on out, we're done with Jupyter Notebooks. I can't think, at least for like this Titanic series that I'm talking about. All right, so I'm going to go ahead. Well, no, I'm going to keep this open because I do need some code out of here. Okay, so I'm going to go ahead and open up IntelliJ. So IntelliJ is my code editor of choice. Other code, this part, whatever code editor you choose doesn't necessarily matter. If you prefer, VS Code's a very popular one. Atom, ATOM, Atom. What is another one? Notepad++, IntelliJ. So these are all the ones that I named are free. There is like a premium version of IntelliJ that I use at work here, but I'm using the community edition on my personal computer here, and it works just fine. Okay, so this is IntelliJ. This looks, actually, I was watching somebody use, I've actually never used VS Code. Prior to using IntelliJ, I was using Atom, and honestly, this is going to sound really like silly, but I was using it because I thought it looked nice. I didn't like the look of VS Code, although VS Code's that's what I was going to say. VS Code's cleaned itself up, and it looks really nice now. But anyway, so off to the left here, you can see our directory structure. So most of these directories have nothing in them. Now you do see that we have like our data up in the top left here, and I hope you all can see this all right. At least within the browser there, I can do a zoom in with the pinch to zoom functionality. I don't think I can do. Okay, I can kind of do that here on my code itself, but I can't really do that otherwise, or at least on the left navigation here. So I like to organize my whole like code repository in this sort of way. And dang, I can't believe we're already at 5:15. I think this is going to end up being a two-parter, unfortunately, because I don't want to miss anything and I don't want to necessarily rush anything. So yeah, so might have to be a two-parter, but we'll come back. I do want to talk about the structure of a repository, and it doesn't necessarily matter about why I organize the way mine is. So I don't, just like you do with any other files on your computer, you can organize it however you want. I purposefully try to keep mine as organized as possible and consistent as possible. So if you go and look at my personal GitHub, you will notice that most of my repositories are organized the same way. So I always put my things, my actual scripts that go in a Docker container in this directory called container. We'll not talk about Docker today, but this is where I'll be putting my API file, because eventually we'll get to another stream where we put this API within a Docker container, and again we'll get to that down the road. Of course, our data directory, this houses our data. We have our dependencies, so we have nothing in the dependencies yet, but this is where I'll put stuff like my requirements.txt file. We'll get more in that down the road. Obviously, the models is where our pickle files are. Obviously, the notebooks are where our notebooks are at. Tests, I like to populate with a directory of test things. And then you might be wondering, what is this dot get attributes or dot get ignore? Um, I'm not, you know what? Actually, I'm not going to cover that because that will take too much time to explain, and that's not why you're here. Excuse me. So, what we want to do is we are going to go ahead and jump into creating an API with what is called Fast API. And before I do that, let me actually just talk about, what is an API? And so the way I like to think about it is kind of like a storefront. A storefront in particular where the inventory is in the back. So, Walmart, all those other places, the inventory is up front. You just walk up to the shelf and you go to the checkout. But let's say, like a cell phone store. Most cell phone stores do not keep, or an Apple store. Or a lot of electronic stores don't keep their inventory up front because they don't want it stolen or anything. So let's say I want a new cell phone. So I walk into a place like Verizon or AT&T. I will tell them I want this iPhone. I want it to have 64 gigabytes and these things. Okay, and they'll say okay, and then the person will go into the back room. At which point I do not see what they're doing. For all I know, they could be having pigeons flying in iPhones to come give them to me, and then they walk out and they hand me an iPhone. So an API is kind of similar in that capacity, in the sense that so in my cell phone example, I am the client, and I am walking up to the storefront, and I'm saying, okay, I have these requirements, or I have this information being the specifications that I want, and I want you, Mr. Store Owner or Miss Owner, to give me back an iPhone. But like I said, we don't know what's going on in the back room, and so that's what's nice about APIs is you can pass information into an API without exposing the backend. So, and that helps with information protection, information security, all sorts of other things. And so similarly, so what we're doing with creating this API, which stands for Application Programming Interface, is we're going to create something to where, let's say I had some Titanic data and I wanted to pass it into the API, and then return an inference on whether or not they think that person would survive. So that's what we're going to be creating. And again, so in this scenario, whenever I'm passing in data to this API, I don't know what's going on behind the scenes. It could be or what we like to call the back end. In our example, was the back room. The back room, back end, kind of similar in this analogy. It could be that the API is reaching out to other areas for information. It could be that it's just doing like some minor calculation behind the scenes. So in our case, what it's going to be doing, as you might be able to guess, it's going to be taking your data and basically passing it through our trained model, which is the pickle file, and then getting our inferences and passing it back to the end user. And so actually writing an API is not too difficult. Like, you can make it really, really complex, but in our case, it's going to be pretty simple. I'm sorry. So I hope I explained that well. Again, I have the questions open down, or my question block thing open down here. So if you have any questions, feel free to ask them. So let's go back to our screen here. I am going to create a new Python file, and it doesn't matter what it is necessarily called. I'm going to call it api.py. So this is our this is the script in which we are going to create our API. So a couple things that we need to do, of course, we need to importing the necessary Python library. So I always like to begin with this library. So we are going to be using something called Fast API, which is a Python library that helps us to serve out API requests. So Fast API is one of the more popularly growing API frameworks. There is also Flask, which has been very popular. I actually used Flask for a very long time. I recently switched over to Fast API maybe like 3 or 4 months ago. And then there's also Django. I honestly don't know much about Django because I personally have not had any need to use it. But if you've used Flask, you'll notice the syntax for Fast API is very similar to Flask. And actually, so never mind. I'm just trying to remember what I was going to say. I don't remember. Okay, so first thing we need to do, we need to import, we definitely need to import pickle. We definitely need to import pandas as PD. We need to import what do you call it? From Fast API. Okay, so this is where I'm gonna have to go back and look at, because like I said, I don't remember everything off the top of my head. I purposely just, I try to make sure I'm directionally correct, and then when I can't remember the precise syntax for something, I will Google it or I will reference my old work. So in this case, I actually did write a full blog post on using Fast API and a whole Git thing associated with that as well. And so just to point out here, we're talking a very similar structure, containers, dependencies, model, notebooks, tests, all the same as what you see before. The only different one here is Kates. So this is actually an abbreviation for Kubernetes. I'm not going to talk about Kubernetes because we're not going to be using Kubernetes in this series. But yeah, so like I said, try to keep things very consistent, very clean. So going into the container file, so this is another API I wrote back. So that what I'm trying to get at here is this little syntax right here. So I need from Fast API import request. So I am going to paste this in here. Okay, and then I also want the response. Apparently I did not do that here. So let me Google that really quick. Fast API JSON response. Return response directly. I think it's called, yeah, it's JSON response. Okay, so, but how do I instantiate it? Okay, there we go. From fast API dot responses import JSON response. Okay, from fast API dot responses import JSON response. Okay, cool. Okay, so that I think is everything that we need to load it. And so I personally also like to, within my actual Python scripts, I like to break things down into what I call like pseudo headers. And so I'll show you what I mean by that. So like I said, you can do comments with the pound sign or the hashtag sign, whatever you want to call it. And then I will, for my headers, what I like to do is I like to do 2 of those signs, and then in all caps, I'll call it whatever the name of the section is. So in this one, I'm going to call this API setup and instantiation. Okay, and then right below it, as kind of like a line break kind of thing, I like to put like 2 more of those pound signs and then just a ton of dashes. And so, okay, so you can see off on the right here that there is like a line over here. This is kind of indicating, you can go beyond this line, but it's basically indicating that most code, as far as formatting goes, doesn't really go beyond that line. So that's why I'm getting as close to the line as I can, and then I'm going to go. I like to put a couple spaces in between my sections. So I always do 3 sections and 3 space or returns in my session here. So, okay. So first thing we need to do is we need to instantiate the API itself. So instantiating Fast API. Okay. So the way to do that is we just say we're going to create an object that's called API, and then we are just going to do Fast API. Nothing inside there. So simple enough. Okay, and then the other thing that we need to do is we need to load up our pickle file. So loading the Titanic trained model. I'm going to call it loading the Titanic trained model. All right, so with open, so within the quotes, we need to get to the models directory. So models, RFC pipeline.pkl. And then we want to do a read binary on that. So we did W before, which stands for write binary. And so we're going to do read binary this time as F. So RFC pipeline equals pickle dot load. Oh my gosh, what can I not remember it? Oh, F, duh. Okay, I just want to check to make sure I did this correct, because we did do this before. Again, I don't remember the syntax on all these things off the top of my head on purpose. It's just too much to try to memorize because there's so much stuff we do within the data science world. So saving, I did a load in here somewhere. Where's the load? Okay, so loading. All right, so as F pickle.load. Okay, oops, got to go back to IntelliJ. Yeah, so that's right. All right, and so that's really all we need to do. for the actual API setup instantiation. So very simple. Again, you can make this thing as complex as you want it to be, but for our sake, we're going to keep it simple. So the next thing that we are going to do is we're actually going to create the different routes for our endpoint. So I'm trying to think how to explain what routes. So let me just call this API endpoints, because this is where we're going to begin defining our different sections or our different endpoints. So when you think about the storefront, there are different actions that you can take. So let's say, so there's, going back to our cell phone analogy, if I were to go to the store, hand them information, and then receive something back, that's what we would call probably like a post request. So we are posting the information up to the API, and we are expecting to get something back. So that's a post. Let's say I've already placed the order, and I'm just coming back in, and I just want to check the details on something. So I'm not really passing in any information at this point. I'm just retrieving information. That would be more of a GET request. So GET and POST, and then there are also different endpoints to do like deletes, updates, and other things. So for our API, we are going to create two different endpoints. One of them is going to be a post request where we post up our Titanic information and we get an inference back on it. And the other one is going to be what we call a health endpoint. And so in case you weren't wondering what a health endpoint is, so when we actually deploy out this API as part of a larger system, we want to make sure that it always has some sort of uptime. So, or like making sure that it's always working as expected. So within Sage, so AWS SageMaker is the service that we will be using to deploy our endpoint. So in order to check to make sure that it's always healthy, they expect a get endpoint with a very specific name that is just basically it's returning basically a tiny little basic text message that says, okay, it's still working just fine. So yeah, let's go ahead and create our endpoint. So let's actually create the health endpoint first, just to get you familiarized with what we're doing here. I actually like to create the predict endpoint first, but so let me just create like a little dummy thing here, defining the predict endpoint. So we'll come back to this one, and then so defining the health endpoint. Okay, so this is where I might have to go back and reference my other file. But basically, the way that Fast API works is you create a function very similar to the other Python functions that we created, where we oh my gosh, I lost my train of thought because I got distracted looking at something. So the thing let me go ahead and pivot to the thing that I got distracted on. I apologize. So coming back to our pipeline here, no, here, the new one that I created. So there is one little gotcha with wanting to use this, and that is the pickle file itself doesn't save the coding and logic for the transformations. It will remember that it needs these things, but it will not actually inherently store that as part of the pickle file. And so the reason I bring that up is because you actually have to load these functions in order to be able to use that pickle file. And so the reason I got distracted is because I didn't do that. And so in order to do that, it's pretty simple. We could load these in line within the same API file. For cleanliness, I'm going to create a different Python file that holds just these things in here. That way we can make use of them from there. So within our container file here, I'm going to create a new Python file called helpers.py. This is typically how we name things in here. And then I'm just going to copy and paste over our different functions here. So, come on. All right, so I'm going to grab the age one. We're going to paste this one over in here. I'm going to grab my embarked one. We're going to do this over in here. Okay. Ooh. There we go. And then, sorry, I'm just trying to get the spacing right. And then the gender one, we are going to just copy and paste over into here as well. Okay, and so this is our helpers file. I can't remember if you actually need to import the same libraries at the top of this in order to make use of them. So we might have to come back to that. But coming back to our API file in here then, so in order to make use of those, so not only can you import different Python libraries, but you can also import code from other files that you've written. So in this case, I'm going to say from helpers import star, and that's basically saying from the helpers file that we have created, import everything that we've created in there. But let's just say, just to be clear, if you only wanted from this helpers file, you only wanted to create age bins so then I'd say from helpers import create age bins like that, and then I could define them all like that. But just to keep things simple again, I'm going to use star because star is going to bring in everything. Okay, so from helpers import star. Okay, so what were we doing? We were defining the health endpoint. That's what I was mentioning. So the way Fast API works is that you basically create your Python function for the logic that you want to house behind that endpoint, and then we set what we call a Python decorator on top of that function that is basically Fast API doing what it needs to do with that respective endpoint. So defining the health endpoint. And this is the part I can't remember. Let's see if I can do it off the top of my head, because this is something I do more often than normal, or more often than like the data science stuff. So API.get. Oh man, I think I'm doing it wrong. Okay, def health. I know I'm skipping down. I know I didn't do this right. So def health and return JSON response. Status, and then we're going to return a little dictionary, status of healthy. Okay, and so like I said, it really doesn't matter what you return as long as you're returning something to know that the health is up. So I think it's api.get, and I think within the function here you actually put what you want the endpoint to be named. So I'm going to call this ping. The reason I'm calling it ping is because whenever you use SageMaker later, it has to be defined as ping. They ask for that. So let's see that if I did this right. So is it api.get/ping? So coming in here. Oh, I forgot about the async keyword. Okay, but I think. Yeah, I actually did do that right. So it is at api.get, and then you put the name of your path in there. Okay, perfect. All right. So that is our first endpoint. So I forgot the async keyword, async. Yeah, so did I do the rest of this right? Okay, so that is the health endpoint. All right, so just to make sure that this works, let's go ahead and test it out. And so in order to test it out, we run everything through our terminal. So as you can recall, so this is the terminal program that I use called iTerm. If you're on a Mac, there is a default terminal program called Terminal. If you are on a Windows machine, you can set up something called Git Bash that kind of emulates this. And so this is how we navigate through our system. And the reason it works kind of better on Mac than it does on Windows is because Mac is built on top of Linux. And so we're basically running Linux commands. And the reason that's important will come down the road later when we start talking about Docker containers. But anyway, to actually start up the API itself, we have to use something called Uvicorn. And so let me just Google what that is. So, and honestly, I'm not super familiar with like why we need to use Uvicorn. So there's Uvicorn here, and then like for Flask, you would maybe use something like Unicorn. So it's basically like a server though. Like it's basically the serving interface for Fast API, and it helps us to initiate that from the command line. So and the nice thing about IntelliJ here is you actually get the same terminal function down here. So everything is integrated within the one thing, the one window here. So I can run the exact same commands. You notice that we are already in our Git repo down here. So what I like to do personally is I like to create shells, what we call shell scripts, which are basically terminal commands that you can run in a consistent pattern. So what I mean by that, so I'm going to create a new file in here called start api.sh. No. Okay, so in here, like let's say I just wanted to do, uh, so all right, down here, let me just do an echo hello world. So what that is just basically going to do, you'll notice that the output is just hello world. So within my dummy shell script here is if I could type the same thing in here, hello world, and let's say I wanted to do another one, hello YouTube, and hello, I don't know, um, I don't know, junk text, there. All right, so these are all commands that I could run within the my interface here, but obviously, it's not great to have to run all these all the time. So if I create a shell script like this, ending in .sh, then down here I can just type in bash and then start api.sh, and oh, that's because I'm not in the right directory. I need to be in the container directory. Bash start api.sh. Then you can see that it did all my commands in here. So, and the reason I bring this up is because whenever we use something like Uvicorn, so Uvicorn, I don't want to always have to type this out and remember it. And this is going to be tricky if I can remember this. I think it is, so you can pass in different flags, which are basically like options that you want for Uvicorn to do. So I think it is host, and I'm just going to do 0.0.0.0, port, I want to do 8080, and then I think it is just the ref. So then you actually, at the end of it, you have to reference the Python file and then the instance of fast API that we created. So the API, the Python file, you'll remember obviously is called API, and then the instance of fast API is also called fast API. So we will just note API : API. Now you don't have to do it like this. You could name these things whatever. You could name this fast API.py, and if you did, you just have to do fast API and then API, or even down in this file, if you were to change this piece into I don't know, ASDF, then in here you just have to change it to ASDF. So let's not do that. All right, and I don't like to have to type all these things out every time. It's a lot easier to just do bash, especially if you want to do multiple commands. It's just easier to have a bash script ready to go. So I'm going to do now bash start api.sh. Uvicorn command not found. Okay, so apparently I've never installed Uvicorn on this machine. Like I said, this is a newer computer. I haven't really used it a ton, so apparently I've never done Uvicorn on this. So Uvicorn, we can do a pip install Uvicorn, and so this will take a couple seconds. So I guess I should have mentioned this too. If you don't already have fast API installed, you have to do the same thing here. You have to do a pip install fast API. So now hopefully this will work. So let's do bash start API, and we should see, looks like something's wrong with my pickle file. So for now, I'm going to comment this out. So what commenting out is doing is basically it's going to turn it into literal Python comments, and so like that. But basically, it stops it from running. So I'm just commenting this out right now because something went wrong, and I'm not sure exactly what went wrong or why it went wrong. So bash start api.sh. So this is the correct interface that you want to see. So you can see here that Uvicorn is now running on port or localhost 8080. All right, so if I actually wanted to call this API, and remember we only have one endpoint right now, so we would be calling 0.0.0:8080/ping. And in order to do that, I'm going to open a second little terminal down here, and I hope you can see this all right. I apologize if it's really small. I unfortunately can't make that bigger. Well, I can make it bigger over here actually, because we don't need to use this. So in order to call an endpoint, we use the standard Linux command called curl. I can't remember what curl stands for, but it's basically the way you call out to the internet to get things. So curl, and I want to do a curl command at 0.0.0.0:8080/ping. All right, and so once I hit enter, we should see a little message that just says status healthy. So let's see if that worked. Yep, it did. So we hit the endpoint, and coming back to our original guy where we had stood this up, you can see that yes, we did one request against ping. So yeah, so that is working. So our API is working just fine. So if you want to shut down your API for now, because we're just running it locally, you can just do the Control-C or Command-C, and that'll shut it down. And then we can do our predict endpoint. So the predict endpoint is going to be pretty similar. It looks like I might have to do some debugging to figure out why this is not working, but at least I can show some of it. And I can't believe how fast time has gone. We only have 5 minutes left, unfortunately, for tonight. So there will most definitely be a part 2. So I apologize that, wow, I can't believe how fast time flies. All right, so similar to our ping endpoint, we're going to create another endpoint called api.post. So this is our post endpoint where we will actually pass up information into the endpoint, and then we're going to call this one invocations. And again, we're only calling this invocations because we are later going to use this with an AWS SageMaker, and it requires this very specific nomenclature. For your predict endpoint, it must be called invocations. For your health endpoint, it must be called ping. I actually would prefer if they called it the predict endpoint. So instead of invocations, it would be called predict. I would actually prefer that. Oh, gosh darn it, I just locked myself out again. I do that at least once a stream. So, all right. All right, so I actually would prefer that because it just makes more sense. I don't know why they chose invocations of all names, but we'll roll with it. So async def, we're just going to call this predict, and so because this is a post endpoint, we want to pass in parameters this time as opposed to the get endpoint where we didn't need anything. We were just calling the endpoint and then we got nothing back. So this time. Fast API is a little bit interesting. So in order to actually get the request from the body or the response, you have to use this request object. And actually, let me check the syntax here because I can't remember exactly how we do this. Okay, so it's just request. Okay, so request colon request. And so what this is basically doing, and this is how a lot of other functions work, it's basically defining that when we pass this parameter in, it must be of object type of this. So in other functions, you could define it as saying that we always want a pandas data frame or we always want something else. In this case, we want request. So first thing we need to do, of course, we need to get the JSON response from the body of the request. So when we pass in from the body of the request, so when we pass in this data, and we'll talk about this more in the next session, we pass it in as JavaScript object notation, which is called JSON. And I'll show that another time, but I just want to get the syntax written out right now. So get the JSON response from the body of the request. The way you do that is, I don't remember. Oh, I forgot about that. Okay, input data. I'm going to call this input data data equals, oh my gosh, why can I not remember? Await get JSON. Await request dot JSON. I think that's right. Going back, checking out my work. Okay, so this is just getting the JSON response from the object of the request. So this input data here is the request body in JSON form. But we are actually going to transform it once again into a pandas data frame in order to be able to make use of it with our trained model. So transforming the JSON into, or input JSON, just want to be super clear, input JSON data into a pandas data frame. Okay, and so in order to do this, this is pretty easy. I'm going to call this input. I'm going to call this input df because we're transforming this into a data frame equals pd.data frame, and then I think we want to pass in input data. Okay, I know I did something wrong, so let me check over here. Oh, brackets. I don't know why the brackets, but the brackets made a difference. Input data. And then we are actually going to get an inference from our trained model. So in order to do that, we are going to pass this data frame into the trained model. So this is very similar to whenever, so coming back to our notebook that we focused on last time, we had created our simple model and reloaded it, and then we got predictions using predict here. We can do the same thing with our pipeline once that is loaded up, which we have loaded up at the top of the notebook here, or at least we would if it was working, but it's not. I know I'll debug that later. I got 5 minutes and then I got to run, unfortunately. So generating prediction from the model. So we are going to do a, so we're going to do the, what did I call it? RFC pipeline. RFC pipeline. Oh wait, now I'm going to call this pred. Pred equals RFC pipeline dot predict. And then we are going to pass in the input data frame. Oscar, I see your question. I'm going to answer that here in a second. Input df. Okay, so that is actually going to generate our prediction. And then I usually like to wrap or create like a little object on how we can. Well, no, I'm going to keep it simple. So we're just going to return this as a JSON response. Return JSON response. Return JSON response. I'm going to call this prediction, and then we are actually going to give it the pred. So this is, again, if you don't remember what the curly braces and the colon like this with the key value pair, this is called like a little Python dictionary. And again, we're returning the response or the prediction back to the caller. So the caller is the API caller. Okay, and that is really it. And so unfortunately, I'm not going to be able to demonstrate this because something is wrong and I don't have time to debug it right now. I'm going to have to wrap up here shortly. But so I do see that Oskan has put a question in the chat. How much changes would one do in the API if not using AWS? Really, you could use this as is. If you're not, so the other platform that I use primarily is Kubernetes. So Kubernetes, you have a container out there. So we're going to containerize this at some point, but basically the container is going to expose the API endpoint in the same way. You could name it whatever you want. It's just that AWS has very specific naming conventions that you have to follow. Like I said, I usually like to call this predict because I think that makes more sense to people than invocations and then a paint, or I call this one health. But this basically you can use the same container on SageMaker or on Kubernetes or anywhere else. It's just that SageMaker requires this very specific naming convention. But great question. So I could use, so to that point, I could use this same API file and the same Docker container that we'll build on Kubernetes, no problem. And I might show that in the future. But for this series of streaming, I'm just going to cover SageMaker. So hope that answers your question. I unfortunately have to wrap this up. I apologize to you all, but this is actually it. I do want to debug why this didn't work, and I'll probably do that in between streams and then figure out what's going on there, and then explain or actually demonstrate how this will work with like actual JSON data and everything. And so we'll do that in the next stream. Time just flew by. I can't believe we're already at time, but I need to wrap up for today. I need to go make dinner. My girls are going to come home. Thank you very much for joining. It's always a blast doing these sessions. Again, Oscar, thank you for joining and asking your question. Please come in with more questions if you have them. I really wish there was a way where I could have like a live thing where people could actually like live interact with me, like almost like a Discord server, but I haven't figured out a way how to do that yet. So if you know a way how to do that, reach out to me. I'd love to hear. Until then, we're just going to keep doing live streams like this with YouTube. So yeah, let's go ahead and wrap it up for today. Thank you all for attending. We will catch you in the next live stream. Thanks all.